Hello, everyone, and welcome to another session from the AWS DevOps course. As usual, let's wait for a couple of minutes for everyone to have a chance to join. And while we are waiting, I have a quick question. Have you succeeded with previous task? I don't know why, but I think this one about the Kubernetes is a bit easier than the previous one. But still, yeah, because in previous one we had to touch so many services in AWS and especially become a knowledge with Terraform. So today we will talk not about AWS but about Kubernetes. But actually, AWS also provides us an option to deploy Kubernetes by, let's say, one click. So you can go to Elastic Kubernetes service, click on a couple of buttons, create a name for your cluster, and look for the underlying infrastructure on which this Kubernetes cluster should be deployed. And this is it. So your cluster will be deployed and will be fully provisioned by AWS, and all of the security stuff, all of the updates and provisioning services will be on the shoulders of AWS. So it's quite convenient. But we will try to understand what Kubernetes is briefly and how can they deploy it by ourselves, so without any managed resources. But actually, I think in the production environment, managed Kubernetes cluster is a must, just because it's much more convenient and much easier for scale. And there are actually plenty of resources which you can leverage using AWS Kubernetes cluster, provisioned Kubernetes cluster. So, for example, you already have all of the logs stored in the CloudWatch. You already have a monitoring for your cluster. So sometimes it's a bit more convenient, but a bit more pricey. So since managed Kubernetes cluster in AWS is not in the free tier, so we'll try to understand what Kubernetes is, trying to deploy it on our local virtual machines. Well, not local, but virtual machines we just deployed in the test number 2. Okay, let's have a look at today's agenda. So first of all, we'll talk about containers. Containers, once again, yeah, we already talked about it in previous course, AWS developer, but let's refresh our knowledge about it once again. Next, we'll have a look at Kubernetes schema. So what actually Kubernetes is, it's not just an application. Okay, actually it is, but we'll have a look at the best practices on how to deploy our Kubernetes cluster. Next, we'll have a look at the Kubernetes glossary, just because Kubernetes has so many terms which you should be acknowledged with, just to understand what's happening in your Kubernetes cluster. Next, we will have a look at the Kubernetes manifest example, so how it looks like and how easily it can be deployed in our Kubernetes cluster. We'll have a look at the service types in Kubernetes. So speaking a bit ahead, so services is kind of it's kind of an approach with which you can expose your deployments in your Kubernetes cluster to the outside world. And in the end, we will have a look at the first task infrastructure and talk about the task itself. So what are the submission criteria, how to check them, and what should be done in this one. Okay, first of all, containers. I hope most of you is already knowledge about what containerization is and what is Docker, how can they leverage it, and what it's all made for. But in a few words, so for example, you have an application and you want to deploy it. And you will need to install all of the dependencies which are necessary for this application to be ran. You need to choose operating system on which it should be ran, and so on and so forth. So there are so many things to keep in mind when you deploy your application. But smart people just invented containerization approach. So you can create your application and create a simple declarative YAML file which will tell what kind of underlying operating system and what are the requirements and how to start your application, just to make it possible for you to give this container to someone, and this person will have a chance just to deploy your application in a few clicks. So something like Docker run or whatever. So with exposing some ports or attaching any volumes if it's necessary. So, but the only problem with Docker containers is, for example, if for some reason your application will catch an error and this error will stop your application. So in this case, Docker container will just die and it will not be recreated just because it's not in the nature of containers. And for such purposes, people invented container orchestration tools. And actually, all of it started with Docker Compose. So it's a chance to create a declarative YAML file, which will say, okay, deploy this container and let them be linked with, for example, this special network. So in this case, all of these containers will have a chance to speak to each other. And if something will happen with this container, it will be recreated just by this Docker Compose orchestration tool. But looking a bit further, next step was Kubernetes. So Kubernetes actually is just an orchestration tool. So we are just describing, but okay, we want in our application to be ran in one replica, so just one container, and it's enough for us. And that's probably it. So if something will happen with your application and container will die, Kubernetes will recreate this container. And one more cool thing about Kubernetes is, what if we are talking about the Kubernetes cluster, which is ran by following the best practices? So you will have a couple of nodes. So for example, node 1, node 2, node 3. And for example, today your application will be deployed in node number 1. But if something will happen with node 1 and it will just go down, your application will just redeploy to the second node. And the same approach, your application will can also be scaled. So it can be scaled on all of these nodes, or even twice, 2 or 3 times on the same node. So you can run as many of your application replicas in the Kubernetes as your underlying infrastructure allows you to deploy. So we are always limited in the CPU and memory. Okay, so with that said, let's move on. Okay, yeah, this is how the Docker file looks like. So this is how you can just describe on what should be done to deploy and run your application. So first of all, you're choosing the how to call it? It's base image for your container. There are plenty of them supported by communities or some application providers or so on. So in this example, you can see that I'm using Python 3.9-slim. And slim stands for as small size, almost as small as possible size of the base image. Next, I'm saying that, okay, we will work in the /app directory, and it will be kind of home, let's say in this case. Next, we are just copying requirements.txt file from our local machine to the image. By running pip install no cache dir -r requirements.txt, we are installing all of these requirements. And when they are just copying all of the files from our local machine to the /app directory, exposing port number 5000 of this container to the outside. So maybe in this case, it may be in our local machine or just whatever you will deploy your Docker container. And in the end, we are just running Python app.py, and this is making our application running. But once again, if something will happen within our application, if it will catch any kind of error, so this container will just go down. And now let's have a look on why should we use Kubernetes. So in comparison with Docker, first of all, Docker is not built for an orchestration. Docker just gives us an option to run in our containers, and that's probably it. But in case of Kubernetes, Kubernetes is automating all of this stuff. So all of the containers, all of the deployments which will be deployed in the Kubernetes will be much more persistent, let's say. Next one is scaling. So if we are talking about the Docker, we can scale in our application. We can just run in our container and that will be probably it. But if we are using Kubernetes, it's as easy as providing the command like kubectl replica count or something like this. And then you need to specify amount of replicas. And your application will, your Kubernetes cluster will create just another replica of your application or as many as you will say it to do. Self-healing. So I think probably like container orchestration. Yep. So it gives us an option for in our application to be self-healed, whatever will happen with it. Automated rollouts and rollbacks. It's one more cool thing about Kubernetes is what Kubernetes actually has different kinds of deployment. So you can just deploy a simple pod, and this pod will be just your container, in other words. So it's just kind of abstraction above the containers to use in Kubernetes. And you can just deploy this container, this pod, and it will be probably it. But you can also create not pod, but deployment. And deployment will be responsible to create all of the necessary pods and all of the necessary underlying infrastructure in your Kubernetes cluster, and we'll have a look for it. Also, cool thing about Kubernetes is that it supports lots of storage orchestration tools. So if you are talking about cloud providers, you can Kubernetes Kubernetes has an API which gives us an option to create NFS share, for example. And it's so convenient. So you can stay at the same YAML manifest in Kubernetes, but you can say, well, okay, I want to create an NFS share using this particular storage class. And the storage class will be linked to the, for example, AWS EFS, and it will create NFS share for your Kubernetes cluster, and it will be fully accessible and managed by Kubernetes in this case. And machine resource management in the end. So in case of Docker, we're just deploying in our containers as much as we need. But if you're talking about the Kubernetes, yeah, it's almost the same. But Kubernetes can handle all of this scheduling stuff. So for example, Kubernetes is smart enough to understand that, okay, this application just requires too much CPU and I can deploy it on node number 1 just because this node will go down or something bad will happen no matter what. So Kubernetes will deploy it on node number 2, which is a bit, stands for a bit less load at this time. And this is how Kubernetes schema looks like. So first thing to keep in mind is what Kubernetes cluster has a control plane. Control plane is a kind of cockpit which handles all of the necessary decisions. So about where should this deployment should be, where this deployment should be deployed, or what are the configuration, where all of it located. So there's so much stuff happening in the control plane. So in production environment, if you're talking about non-managed Kubernetes cluster, so it's a good idea to have this control plane to be backed up. So it may be ran in, for example, 2 replicas. And in this case, if anything will happen with the control plane node, the second one will take the action and will become the master one. And in this cluster, every cluster will also have worker nodes. Some examples, or maybe if you will try to play with Kubernetes by yourself, for sure you can just deploy one node, and on this node will be running the control plane and the worker node as well. So it may be even your local PC, where you can just deploy this Kubernetes cluster, and it will be enough to run some deployments on this Kubernetes cluster. But in this case, yeah, we can't guarantee high availability of this cluster, just because if you will close your laptop and it will go to the sleeping mode, your cluster will go down. But if you are talking about, if you can see at the right side, there is cloud provider API mentioned. So If you are talking about managed Kubernetes cluster, and as a production must-have, as I already mentioned, so Kubernetes cluster can talk to the cloud provider's resources, can scale virtual machines on which it's running. So in case of AWS, it can be, for example, AWS Fargate. So we can say within our Kubernetes cluster will run on AWS Fargate, and all of the nodes will be provisioned by it. So we don't need to care about any any uh, any underlying resources. One more thing for mentioning at the beginning. So what if we're talking about Kubernetes, the smallest part which we can deploy is pod. As I already said, so pod is kind of abstraction above the containers. So actually inside of our pods, the same, okay, let's call them for now Docker containers will be running. But actually more than one container can be running in one pod, but usually it's just separated, so one node per pod. And in this pod was created just not to stick to ephemeral networking resources. So if you are talking about the pods, so whenever pod is created, it will be assigned with the service. And service, you can think about it as a network interface card. So it will give this pod an IP address, which will be known for all of this cluster, and all of the other pods will have a chance to reach this one. And if something will happen within our container, so if in our application will just crash or something like this container will be recreated, but inside the same pod. So the pod will be pod will also be recreated, but the IP address will stay the same. So this is why it's done in a few words. Okay, quick glossary. So yeah, as I already mentioned, pod, the smallest deployable unit, which can contain one or more containers. Just keep it in mind. Service, a stable network endpoint to expose a set of pods, or just one single pod. So you can just manage what kind of IP address should be allocated. And if you're talking about managed AWS, managed Kubernetes clusters, so even Elastic IP address can be attached, or even load balancer can be created using Kubernetes clusters. So you can create a special service which will create load balancer in your AWS account, and via this load balancer, your deployment in Kubernetes cluster will be accessible. So it's a quite cool thing and worth understanding. If you're talking about deployment, so deployment manages the set of identical pods and ensure desired number of pods are running. So this is what we've been talking about, self-healing. So if something will happen with one of the pods, deployment will recreate them. Namespaces provides us a way to divide cluster resources between multiple users, but actually not only users. Sometimes it's convenient. So for example, you may have an application and you may have some monitoring resources for this application. And you can separate them by namespace. So it will be more convenient for you just to understand what are the deployments in your Kubernetes cluster. You will just go onto the namespace and try to find out what exactly deployed in this namespace and what the purposes it serves for. Config map. Config map is a thing which gives you an option to manage your application behavior, not by changing application itself, but by changing some values in the config map. So it's kind of configuration which is deployed and openly accessible, easily accessible from the Kubernetes cluster. So you can store some, for example, some kind of ports, or maybe some kind of, okay, if you're talking about certificates, we will talk about, it will be not config map, but secrets, but I can't see them here. Oops, my fault. Okay, so keep in mind, we don't have only config map. We also have a possibility to store secrets in Kubernetes cluster. So we will store it secretly in Kubernetes cluster, and all the secrets may be accessible and used by your application, or by, for example, fetching the image from some external sources. Persistent volume claim is it's the same. It's actually resources which we can use to make persistent storage, surprisingly, for in our application, for in our pods. And if in our pod will be recreated, and if it will be recreated with the same name, or we will have a special policies on this persistent volume claims. So the storage will be reattached to the new pod, and the data will be persistent between the life cycle of this exact pod. Note, it's just a worker machine. So if we are talking about the cloud native approach, it will be for sure virtual machines. kubectl is a command line tool which gives us an option to talk to in our Kubernetes cluster. So all of the commands will start with kubectl, and then you will have an option to run kubectl get pod, kubectl get all, kubectl delete, describe, so just whatever. Even making a rollout restarts of your deployment or making updates. So kubectl can handle it granularly, following the best SDLC practices. Diamond said, it's actually a cool thing. So Diamond said just ensures that all of the nodes in this particular cluster will have at least one pod with some particular deployment. So we can describe it. Okay, with Diamond said, we want to deploy in our monitoring tool, which will fetch all of the necessary metrics of this particular virtual machine. And this, whenever we will deploy this Diamond set, it will be deployed on all of the nodes in our cluster. So it's kind of cool and convenient thing to use in such cases. Service account. Service account actually just gives us an option. It's just an IAM role in like in case of AWS. So we just giving this to someone and they giving someone an option to do something in our cluster. So something like this. Resource quotas. We can also specify resource quotas, which is necessary, which will be the bare minimum for an our pod, or which will be the maximum it can handle from some particular nodes. And Kubernetes cluster will have it in mind and will not schedule these pods if this particular node it doesn't have sufficient amount of resources available. And horizontal pod autoscaler. Actually, it's a kind of plugin for the Kubernetes, but it gives us an option fetching the load of some particular pods, and in case this load will reach some threshold, Kubernetes will take care about creating another replica of your application. And since in our application will be hidden behind the IP address, so maybe load balancer or something like this, whatever. All this load will be spread among all of the existing pods of your deployment. Okay, and this is actually how simple manifest looks like. So, and if I recall correctly, so you will be asked to deploy such kind of deployment in your Kubernetes cluster, which you will create in the task number 3. At the right hand, you can see 2 manifests. So first one gives us an option to create a pod. It will be a single pod with Nginx on it. So as you can see, okay, unfortunately, this line's not enumerated, but let's have a look at the spec. Where is the most interesting part. Just because in spec we are describing which kind of container, which kind of image we want to deploy in our pod. And in this case, it's just a public Nginx server. So the image from the Docker Hub will be pulled by this Kubernetes cluster with version 1.14.2. It will be deployed, and port number 80 will be deployed. So this is probably it. But this pod will still not be accessible from even from your local machine or from the virtual machine you are running your Kubernetes cluster, just because we don't have the service. And to create the service, we have manifest at the right. So this is just a service. As a metadata, we are just providing the name of the service. We are specifying the selector. So by selector, the service will try to find the deployment, the pod, which is named Nginx, and it will expose port number 80 of application to the port number 80 of your okay, in this case, it's not port. Yeah, so it will be accessible at the port number 30007 of IP address of your node where it deployed. And to deploy all of this, we only need to run kubectl apply, kubectl apply, kubectl get pods just to verify everything is deployed and that in our pods in the running status. And if you want to have a look inside of this pod, if you want to have a look at the logs of this pod or what actually happening with this pod, so we can run kubectl describe pod nginx. And few more things about service types. It's quite crucial to understand just because sometimes it's a bit confusing. So we have couple of service types in Kubernetes, but with some plugins, this list may be extended, but still, this is the default ones. So first one is cluster IP. So it just exposes the service of an internal IP in the cluster. In this case, your application will only be accessible inside of this cluster. So it's made just, for example, if you have a database and you need to expose it for a database pod, and you need to expose this database pod to your application pod, cluster IP will be the best choice, just because you will deploy it only for the deployments inside of your Kubernetes cluster, and your database will still be not available from the outside of this cluster. Next one is not port. I can't say if it's helpful in the production environment, but in this case, it's just exposing your deployment to the IP address of your node. For example, if we are talking about EC2 instance, so this particular service will expose your application to this EC2 instance's IP address. If we are talking about your local machine, so yeah, you can even reach it via the local host. Load balancer is the most powerful thing, I think, just because it gives us an option, I believe, as you mentioned, to create a load balancer and point this load balancer on all of the nodes of this Kubernetes cluster. So it will give you, and this load balancer, also Elastic IP address, okay, in case of AWS, will be created, and your deployment will be publicly accessible. And external name. I never used this one actually. So maps the service to a container of an external DNS name. Okay, makes sense. So I believe it may be convenient sometimes, but yeah, in production usually we are using load balancer. And this is how our infrastructure should look like. So I believe you already saw this picture in the test number 2. But what is changing? First of all, we just got rid of one of the virtual machines in our public subnet. So we don't need it anymore. And the best case scenario is if you can deploy Bastion host, first virtual machine. And then you will need to connect to this Bastion host via the SSH, and then connect to the virtual machine in the private subnet, just to deploy Kubernetes cluster in it. And in this case, your Kubernetes cluster will not be exposed to the outside of the world and will only be accessible from the Bastion host. Once you are done deploying Kubernetes cluster on one of these machines, so you also have an option to register another node in your Kubernetes cluster. And following the instructions which are given in the task number 3, we will have a look at it now. So you will have an option to create Kubernetes cluster consisted from 2 nodes. Okay, if you have any questions, it's a good time to ask them while I'm rearranging my screens just to... Okay, what about replica sets and stuff? Yeah, exactly. So we also have different types of, but I think it's a bit more complicated topic. So in case of stateful set, we just have an option to deploy in our deployments with some persistent names. So, and it's very useful if we are talking about the database clusters. So for example, there is, so So, for example, we are deploying Postgres cluster, and it consists of 2 or 3 replicas. And okay, yeah, I'll have a look at the rest of the questions a bit later. So, if you're talking about stateful, it just gives us an option to create consistent and consistently named resources, which will be scaled by appending, for example, one digit in the end. Um, and whatever will happen within our pods, it will be recreated, keeping in mind what the structure should stay the same. But all of these pods are um, not stateless, but stateful. So we need to care about their state and about the storage it's connected to. So and about replica set, so it just gives us an option, yeah, to create deployment which will hold which will hold a specified amount of replicas of our application, and it can be scaled easily with one command, I believe. Restart it, update it, and so on. Okay, do we need any workload with the internet in the following tasks? Not really. So since the last time, we had just decided to move uh, to deployments even on your local machine. So once you will be done with task number 3, you can just deploy the Kubernetes cluster using Minikube on your local machine, and it will be enough for you to follow all of the further steps. We did it just because if you are talking about the free tier in the AWS, we are only able to create micro instances, which are sometimes are not enough to even handle the Kubernetes cluster. Yeah, it will be kind of pain. I don't know, maybe something's changed since the last 6 months, but yeah, I will have a look. But uh, so creating the Kubernetes cluster for creation the Kubernetes cluster in the AWS, microinstances is enough. But if you will deploy any deployments on these instances on this Kubernetes cluster, it will be kind of pain, just because we are not enough of resources, and you may fetch some lags and some outages. Your virtual machine may just freeze, and yeah, it's so inconvenient. So we will just stop using virtual machines once we are done with task number 3. Bastion host or Ethernet gateway required? Actually, it's required just for your instances which are located in private subnet to have an access to the internet. But what can be done actually is you can create. Okay, but in this case, Bastion host is absolutely pointless. Mm. Okay, so why not? Actually, you can just create 2 virtual machines which are specified on the right side of the screen inside of a public network. In this case, unfortunately, they will be publicly accessible, and Bastion host will be absolutely pointless in this case. But you will have an option to avoid keeping NAT gateway to be deployed on your account, so you will not be charged for it, and it will be enough to create just internet gateway if you don't have any, and it will be enough for your instances to be accessible and to make it possible to install Kubernetes on these virtual machines. If we want to manage cluster with kubectl on our local computer, how do we achieve connectivity to the clusters? Yeah, exactly. But actually, it's maybe a bit better approach just to manage this Kubernetes cluster from the Bastion host. So you will connect it with Bastion host, and you will manage your cluster, and this is it. But yeah, if you want to manage it from your local machine, you always can create a reverse proxy, which will be enough to connect to your Kubernetes cluster via the Bastion host directly from your local machine. Okay, now let's have a look at the task itself. Mm, bear with me for a second. Just missed this button again. Where is it? Okay, here we go. Yep. So yeah, as you can see, for some reason we just forgot to remove it from here, but it's not necessary at all. What we need is we need just to deploy Kubernetes cluster on our virtual machines, which are hidden behind the Bastion host. But once again, if you struggle with handling, okay, where is that gateway? I don't know on this screen. Oops. Okay, never mind. So yeah, you can choose to use, you can choose to deploy these virtual machines right on the public subnets, and then your Kubernetes cluster will be accessible just from the internet, from even from your local machine. Here you can find the fulfilled instruction on how to deploy K3s. Now, K3s is kind of lightweight Kubernetes. But for the understanding how Kubernetes works, how to deploy your workload in the Kubernetes cluster, and how is the communication between your worker node and control plane works, K3s is just enough. So it may be installed with one simple command, and using one more simple command, you can even connect the second node to your control plane. Sorry. Use EC2 instances from the free tier to avoid additional expenses. But yeah, if I recall correctly, so on the previous run of this course, we had some difficulties deploying Kubernetes cluster with some workload on the micro instances. It actually can be handled by the problem was with the memory. So if you find out how to create additional memory using swap, your cluster will be a bit more stable. And these virtual machines can handle a couple of deployments. Create and extend Terraform code only if it's necessary. I don't think so. You can just adjust it and maybe get rid of some unnecessary resources. Maybe some security rules will be necessary just because for control plane and node to communicate to each other, some of the ports should be opened. Ensure the code includes the creation of a Bastion host. Okay, makes sense. Deploy Bastion host, deploy Kubernetes cluster using K3s. Ensure the cluster is accessible from your Bastion host. To make it, you can just run any simple command. So, for example, kubectl get namespaces, get an S, kubectl get pods, or just whatever, just to make sure with your Kubernetes cluster answering to your commands. And provide a screenshot. Oh, okay. So here we have a couple of commands needs to be run. Ensure is accessible from, okay, and additional task, make it accessible from your local computer. Yeah, in this case, what I mentioned. So you will need to set up the reverse proxy. Run the kubectl get nodes command from your Bastion host to get information about the cluster. Okay, this is actually the same as here. So you just need to verify that your cluster is operating normally. And then deploy a simple workload. So in my presentation, you saw what I specified the exact manifest file, which is like which was in YAML format. But if you will have a look at this one, so I believe it will be the same. Case. Oh, fortunately, I had an issue with my PC, so I lost all of the programs. So yeah, this is how it looks like. So pretty the same. This deployment is the same as I shown in my presentation. So by following this simple command, kubectl apply -f, you will just deploy this pod. Okay, where is it? Come on. You will just deploy this pod in your Kubernetes cluster. You will also need to deploy the service just to make it available from your at least Bastion host, I believe. There is nothing about it. Okay, maybe it's just enough. If you just want to run some tests on this Kubernetes cluster and try to understand how it really works, so you can also deploy a service to make this deployment available. Because in our way, it will be not accessible even from your Bastion host or even from the local nodes. And as an additional task, document the cluster setup process in a README file. So you will just need to create or add some information in your README file about how to set this cluster up and how to connect additional nodes and how to deploy all of the deployments. Okay, submission. So right now you should have the main branch of your repository fulfilled with task number 1 and number 2 pull requests. So all the information should be already in main. So you will need only to create task number 3 branch, make all of the necessary changes to your code, and create a pull request once again to your main branch. And then submit this pull request link to the cross-check. That's it. Provide a pull request with the Terraform code for the Kubernetes cluster and Bastion host. Actually, you can even, yeah, I'm not sure what you can set up Kubernetes cluster manually, or if you are brave enough, you can even make this Kubernetes cluster installation. You can make it by user data in your virtual machines. So in user data, you can specify all of the commands that should be ran just to create your Kubernetes cluster with the virtual machines provisioning. It's not a must, but yeah, will be quite helpful for you to understand how user data works for virtual machines. Provide a screenshot of the kubectl get all namespaces command output. You will need to run it from your Bastion host or from the local machines. Now, where Kubernetes cluster is running. Provide a screenshot of the kubectl get nodes command output, just to make sure what both nodes are. What your cluster consists of 2 nodes right now. And provide a README file documenting the cluster setup and deployment process, just to handle the additional task. And this is probably it. So once you will get for submissions to check, you will need to follow this evaluation criteria, have a look at it, and just align them with the align these options with the with the cross-check submission, and just mark the points. That's probably it. Any questions? But the second node will need registration token from the master node to join the cluster. How to achieve this with user data? Yeah, it's quite complicated thing. You can think about it like to store this information somewhere in the AWS, for example. So you have SNS or SQS. So okay, actually, I can come up with some ideas on how to do so. But I believe it's possible. So when creating your first node, you can just store the information about the secret token somewhere in the SQS. And then you will create, okay, but in this case, you will need to specify which node is primary and which is master. Yeah, it's kind of inconvenient. I don't know, but if you'll come up with something, yeah, just let me know, because I'm curious. I believe it's possible. Maybe not that convenient as easy as it sounds like, but yeah. Okay, makes sense. Makes sense. Navizusan, yeah, but I will have a look. Any more questions? If you don't have any right now, but if you will have any further on, you can always find me in the Discord. So feel free to ask all of the questions which are bothering you. If you have any difficulties or questions about the cross-check, once again, reach me in and I will try to help you. And I believe on the next week, we will meet to talk about the CI/CD tools, and it will be Jenkins. Yeah, a bit different picture, just because we will get rid of the Kubernetes, just not to spend money on AWS anymore. Okay, then. Thank you so much for being here today. Session over for me. See you in a week. Bye. Have a good rest of the day. See ya.